Hi, today we are going to present the fabrication of a peristaltic pump. These are the group members. Number 1, Nur Aisyah binti Muhammad Zaidi. Number 2, Muhammad Izul Iman bin Samsul. Number 3, Muhammad Syaib bin Syari. And number 4, Ne'edroli Anak Noin. Hello everyone and welcome to our video presentation. We are from Group 4 and today we are excited to walk you through our workshop project titled The Fabrication of a Peristaltic Pump. In this video, we will be talking about safety equipment and technique, manufacturing process involved, problem phase and solution, and lastly, discussion. So, let's go to our first slide. For content of presentations, there are role of members, introduction, safety equipment and technique, manufacturing process, problem phase and solution, and finally, discussion.
Here are the role of members for this project. For part 1, which involved lathe operations such as cutting, drilling and tapping, Nay was responsible for carrying out the boring and drilling operations using the lathe machine. Meanwhile, Shahib handled the surface preparation and material cutting using the lathe machine and the angle grinder. For part 2, which included marking, cutting, milling, drilling and tapping, Izul was responsible for cutting, grinding and drilling of the workpiece, and Aisyah was responsible for performing precision measurement, milling, tapping and filing operations to ensure the workpiece achieved the required dimension and good surface finish. Now, I would like to explain the safety equipment used during the machining process. Before operating any machine, we wore the appropriate personal protective equipment to ensure safety in the workshop. The safety equipment included safety boots to protect our feet from heavy objects, a workshop jacket to protect our body and clothing, safety goggles to protect our eyes, and safety gloves to protect our hands while handling the workpiece. Next, the machining technique used in this project were turning, facing, boring, drilling, threading, and chamfering. Turning was used to reduce the diameter of the workpiece, while facing was performed to produce a smooth and flat end surface. Boring was carried out to enlarge an existing hole accurately, and drilling was used to create holes in the workpiece. Threading was then performed to produce screw threads, while chamfering was used to remove sharp edges and improve the finishing of the workpiece.
Moving on to part 2, this focus on processing a steel plate through milling machine operation and precise bench work. First, we mark the steel plate using a scriber and ruler according to required dimensions. Next, onto the milling machine. The workpiece is securely set up on the milling machine's vise. We perform a surface cuts to reduce the dimension until the total thickness is 4mm. Right after that, a side cut is performed until the overall length of the workpiece is exactly 45mm. Next, the workpiece is measured for drilling operation. 3 holes are initially marked using a center punch. The drilling process is then initiated carefully to produce the 3 marked holes. The outer edges are ground to make a fillet profile so it can fit perfectly into the main workpiece. After that, a tapping process is then conducted on both sides of the hole created to an M6 thread. Finally, the workpiece is filed thoroughly to ensure clean and smooth surface finish. On to the turning process, which we utilize the lathe machine. Step 1, we begin by removing the outer layer of the workpiece by using a turning and facing technique. Next, we make a true hole right at the center of the working piece using drilling technique. After that, we make the blind hole larger by using a boring technique to a diameter of 50mm to create our first counterbore. The second counterbore of 45mm is made using the exact same boring technique. After that, we cut the workpiece length down to 21mm using an angle grinder. Next, the workpiece is reversed and we drill a blind hole at the back of the workpiece. The blind hole need to be bored at final diameter of 90mm, and last but not least, the hole at the side and the bottom of the workpiece were drilled using a bench drill.
Assembly process of the peristaltic pump. First, insert a countersunk flat head screw into the center hole of the second part. Place a washer onto the screw, then secure it by tightening a nut from the back of the component. Second, move the two bearings onto the side holes of the second part. For each bearing, use a countersunk flat head screw and a washer to fasten it securely. Third, insert the assembled second part into the first part, then attach the remaining bearing using a countersunk flat head screw and a washer to secure the assembly in place. Finally, install the hose by inserting one end through one of the side of the holes of the first part. Loop the hose around the outside of the second part so that it is pressed against the bearing. Then guide the other end out through the opposite side hole of the first part.
These are some of the problem faced and solution during fabrication of a peristaltic pump. So the first problem is improper surface finish. The solution for this problem is increase the cutting speed and use sharper tool to achieve smoother surface. And for the second problem, improper edge radius. To overcome this problem, adjust the edge radius little by little into the required radius. And the third problem is rust formation. Apply oil into all the surface of the workpiece to prevent oxidation process. And for the last problem is tool shortage. The solution are ensure all the tools needed is ready at the working station. And for the last slide of our presentation is discussion. To improve this project outcome, the action that we can make are planning the process workflow for smoother working operation and eliminate the product error. And the second action is standard operating procedure. SOP should be strictly followed to reduce cycle times and manufacturing defects. The third discussion is appropriate high tolerance tooling must be selected to achieve precise dimensional control and optimal product quality.